Professor Bialis here. In this video we're going to be talking about section 11.1 where we cover the square root property and completing the square. What these will allow you to do is solve a quadratic that is not factorable. Okay, and even if it is factorable, but it will allow you to solve it when it's not factorable. Up until this point, whenever we got a quadratic equation, I always said it's factorable, it's factorable. That may not be the case anymore. But if it's not, that's okay because we have these other options at our disposal. Okay, so let's start with the square root property. It's a very simple thing, but I want to make sure that we understand it because that's the basis for completing the square. So let's look into this. Let's say we have something like this. Okay, and we were solving that quadratic. Now, before we cover anything new today, okay, we could look at this and say, well, I'm going to factor that difference of squares. And then set each of those equal to 0. Okay? We would subtract that 3, and we would add this 3. And we get those answers. And that's perfectly fine. There's another way we could approach it, though, and that's using the square root property. So let's see that in action. Same problem, but again, a different approach. Let's say we didn't factor, but instead we isolated that x squared. That would mean I add the 9. Okay? Now remember, this is an equation. What you do to one side, you do to the other. So what could I do to an x squared to make it just a nice x? Well, I could take the square root. And that gives me x equals square root of 9 is 3. Now notice the difference though. I got a 3 here. Here I got a 3 and a negative 3. Okay? Remember, 3 squared is 9. But negative 3 squared is 9 as well. So here's the little trick with the square root method. That's what I was doing here by taking that square root. Whenever you take the square root of both sides, you must include the positive and the negative version of that radical. Okay? This symbol right here is almost like a listing symbol. You have a positive 3 and a negative 3. Okay? It's not one or the other. It's this and this. And this is your result using the square root property. Okay? Again, could we have used factoring? Yes. But we have this at our disposal now as well. Now, what this is good for is, what if I give you this? Now, you would look at that and say, well, that's not a difference of squares, so I can't factor that. No problem. Use the square root property. Instead, add the 43. And then take the square root. Don't forget, plus or minus. And I can write square root of 43. And there's your answer. Okay? Or something like this. I can't factor that. It's not a difference of squares. It's a sum of squares. No big deal. Subtract the 25. And we can continue. Because when we take the square root, remember now we have complex numbers. So we can say x equals plus or minus, don't forget that, square root of 25 is 5, with that negative, 5i. And there we go. Okay? So again, we can, if it's factorable, still do this. But if it's not factorable, we can then approach it this other way. Okay? Let's look at a couple other ones. Okay. Now we could factor out a GCF of 5, but then what we're left with is still not a factorable binomial. So instead, let's add the 55. And then divide by 5. And now, don't forget, plus or minus square root of 11. And there we go. This doesn't mean that factoring doesn't work. That doesn't mean that factoring is garbage. This is just another option now. Okay? Now this option is only useful in specific situations. When you have a single x value in there, like this, or a single squared value that you can isolate, or a squared component that you can isolate. Okay? Let's look at a couple more like this. Okay, we have this. Again, it's not an x squared that we have in it, but we have a quantity squared that we can isolate. Okay, it is isolated, but we can isolate it. Okay, now how do we do that? We take the square root again. Now watch how we're going to write this. Square rooting something squared just drops out that base. We automatically put the plus and minus whenever we take the square root of both sides. And then we have that root 18 that we can simplify. 18 is going to be 9 times 2, or 3 root 2, because square root of 9 is 3, and then the 2 stays in. Now, we're not done, because the x then has to be isolated. We got rid of the square part of it, but we need to isolate the x. So I'm going to subtract a 2 to get x equals. Now, here's something we got to remember. Just like we always say 5x, we never say x5. That's just not how it's written. Whenever you have that plus and minus symbol, always put that term last. So what I'm going to do is write this as the negative 2, then the plus and minus 3 root 2. It wouldn't be wrong if you flipped it. It's just a little easier to work with this type of layout. Okay? And there we have it. Okay, let's look at one more. Okay, we have that quantity that's squared, isolated. Let's use the square root property. So I'm going to square root, drop this out, make sure you automatically plus and minus, but then what's the square root of negative 4? Don't say it's not a real number. We can still work with it, okay? And what we get is a 2i, okay? Now, if they specifically said, find the real solutions to this, then you would just say there are no real solutions. But if they just say solve, real, complex, anything's fair game. And then let's isolate that x. So I'm going to add a 1. And just like before, 1 plus or minus 2i. And then to finish, I'm going to divide both sides by 3. Now, if they say to write it in that a plus bi format, this would normally be fine, but if they specifically say a plus bi format, then they want you to separate this like so. Personally, I'm okay with either of those, but if the instructions specifically say a plus bi standard form, they need you to break it up like this. Okay? So that is the square root property that cannot be used every single time. Okay? Factoring can be used when it's factorable. This can be used when you have a quantity or a term that is squared that can be isolated like these. Okay, the next thing that we're going to talk about is called completing the square. This can literally be used every single time. Factoring cannot always be done. This cannot always be done. Completing the square can. Okay, so let's see how that's going to play out. Okay, let's start out with something like that. Okay, now if we were to solve this and we think, oh, it's equal to 0, I'm going to try and factor. Can we factor that? There's no way of multiplying to a 1 and then adding to an 8. Then we're going to say, oh, I'll use that square root method, that square root property. I can't do that here either because I can't isolate this x squared without having an x on the other side. This is a situation where that square root property is just not going to work. So that brings us to completing the square. Now, completing the square is a very routine process, but we have to get used to that routine. First thing, I'm going to make a list of steps right here. First thing you want to do is isolate the constant. In this case, that means adding a 1 to both sides. Like so. Okay? Now, the second thing you would do is divide all terms by the a in ax squared plus bx plus c. Now what I mean by that is you have your coefficient of x squared. This is a 1 here, so if I divide everything by 1, that doesn't do anything. But if this is a 2, I would divide every term by 2. The reason being, I want this value out in front to be a 1. I need that to be as blank of a slate as I can make it. Okay? Now, step 3 is to add to both sides b over 2 squared. Okay? Now that b is the coefficient of x. So what I'm going to do is I'm going to take that 8 divided by 2 and square it. What that gives me is 8 divided by 2 is 4. 4 squared is 16. But if I add it to this side, I add it to that side. Okay, now what I just did by following those 3 steps is I created a perfect square trinomial. Okay? Perfect square trinomials will factor into a form like this. When I factor this, all I need to do is take the square root of this, square root of this, and then this sign right here. That's it. If you look back, I believe it was section 6.3, when I was introducing perfect square trinomials, I then multiplied these and then I doubled it to verify that middle. That was because I wanted to verify it was a perfect square trinomial. I made this a perfect square trinomial, so I don't need to check that it is. I made it happen. So I can just square root, and then bring that plus sign down. Now look at what we created. This looks an awful lot like this. Completing the square is not a standalone thing. Completing the square simply sets up the square root property. Because now I can take the square root, get an x plus 4 dropping out, then plus or minus root 17. Subtract the 4. And there we go. Okay? Now, the reason why we're doing this right here, when we dealt with perfect square trinomials, we had something like this. Okay? We want to have a 1 here because then this does not really factor into anything. Because if I just multiply by a 1, no big deal. Okay? Why am I dividing by a 2? Because I want this 2 to be kind of stripped away from the problem. Then what am I left with? I'm left with a b. If I square it, I get that third term. So what I'm doing is I'm trying to force this pattern into that trinomial so it factors like this, so I can use the square root property. Okay? That's pretty much it. After we added that to both sides, we factor and solve using the square root property. Okay? All we're going to do from here on out is a few more examples. There's nothing else for me to show you on this though. You know everything there is to know about completing the square. Okay, but remember, it is not a standalone thing. It is simply a way to set up that square root property. Okay, so let's look at a few more examples. Okay, so first thing we are going to do is we are going to move that constant over. So I'm going to subtract a 2. I got that. Then I'm going to take this number and divide everything by that. But if I divide by 1, that doesn't do anything. The only time you have to focus on step 2 is if there's a number other than 1 there. If it's a 1, then that division is not going to do anything. Then I am going to take that middle coefficient, divide it by 2, and square. Okay? Now don't take 5 divided by 2 and say 2.5. Just leave it as 5 over 2. Okay? 5 squared, or negative 5 squared, is 25. Two squared is 4. And we got that. Okay, we add it to both sides to keep it balanced. Now we should factor, and the factoring should be very easy. This isn't something you have to dig into. Just use what you have in front of you. Square root is y. Square root is 5 over 2. And I bring down the minus sign. You might be thinking, well, wait a minute, what about that 5? That 5 is going to work itself out. If you were to write this out twice and FOIL it, you're going to get that 5. It should work itself out because we strategically picked that number. And then that equals, I'm going to write this negative 2 as negative 8/4. And that gives me a positive 17/4. Because negative 8 plus 25 gives me 17. After that, I'm doing the square root property. Drop this out. Plus or minus, square root of 17 over 2. Don't forget that plus or minus. And then I finish by adding 5 over 2. And there we go. If you want to write those two answers out, it would be a 5 over 2 plus root 17 over 2 and a 5 over 2 minus root 17 over 2. Again, we're just kind of shorthanding it with that plus minus notation. The other thing I want you to realize, honestly, I would leave it as is, but if you wanted to, you could write it as a single fraction since they have that common denominator. Again, I wouldn't go out of your way to do that unless they specifically ask you to. I would just leave it as separate fractions. Okay, let's look at a few more. So again, you want this to feel like a routine. I'm going to subtract the constant, or in this case, move the constant over. So I got 5x squared minus 10x equals negative 2. This is where step 2 is going to come into play. I'm going to divide everything by that 5. Why? Because I want that to happen. Okay? So I got x squared minus 2x equals negative 2 over 5. Then I take this negative 2, divide by 2, and square it. Negative 1 squared is 1. After that, the factoring should be a piece of cake. Square root is x. I bring down that minus. Square root is 1. Negative 2/5 plus 5/5 is 3/5. Okay? At this point, square root property. Again, completing the square is just a setup. It's not a standalone thing. I'm going to take the square root, drop out x minus 1. Don't forget that plus or minus. Now here, you need to rationalize that denominator. I would do that before I go any further. So I'm going to multiply by root 5 and root 5. That gives me square root of 15 over 5. Okay, then add the 1. X equals 1 plus or minus root 15 over 5. Again, you could change this to 5 over 5 and pull it together. I wouldn't bother. I would just leave it as that. Okay? So get a couple more. Okay, first thing, constant moves over. Next thing, divide everything by that leading coefficient. Next thing, I'm going to take this coefficient, divide it by 2, and square. So I'm going to get negative 1 squared is 1, 2 squared is 4. And I'm going to add that to both sides. Then this should factor nicely. Square root is x, bring down that minus, and then square root is 1, square root is 2. I then have to add that other side. I need a common denominator, so I'm going to think of this as negative 14 over 4, multiplying each of those by 2, plus 1/4. That is negative 13/4. Again, don't rush through this. If you need the calculator, fine, but if that's something you're slow with, practice these fractions, because the fractions are typically not too complicated and it gets you more used to the basic routine of adding and subtracting fractions. Now, square root plus or minus, and then here I have a negative under there, so I'm going to have a complex value. I'm going to think of this as two separate radicals. Square root of negative 13 is I root 13. Square root of 4 is 2. I then add a 1/2. So x equals 1/2 plus or minus I root 13 over 2. Again, you could pull that together under a single denominator, but it's not necessary. I'll just leave it as that. Okay? Let's do one more to finish this up. Okay, what's really nice about this is the fact that we already have that constant over, so we don't have to mess with that. But then we go into dividing everything by 3 because that is the leading coefficient, and we want that to happen. So we get x squared minus 4/3 x equals 4/3. At this point is when we would divide by 2 and square. Okay? Now watch this for a second. If I just take negative 4/3 divided by 2 and I square, do you see how messy this is? If you have a fraction as that b value, my suggestion would be don't divide by 2. Multiply by 1/2. Same thing, different look, different feel. Instead of dividing that by 2, multiply it by 1/2. That way, this is a lot easier to handle because I got a negative 4 over 6, which I can simplify to a negative 2 over 3. And then when I square it, negative 2 squared is 4, 3 squared is 9. Okay, so again, if you have a fraction here, I wouldn't divide by 2, I would multiply by 1/2 just because the rest of it is much easier to work through. Okay. Also, if you haven't noticed so far, I'm always adding on both sides. I'm never subtracting because I square this term. So even if it was a negative, if I square it, it's a positive. If it's a positive, I square it, it's still a positive. I'm always adding on both sides. Okay. Now, this should factor nicely. So x square root of x squared is x. Bring down that minus. Square root of this, square root of 4 is 2, square root of 9 is 3. And then I have to add this. So I am going to look for a common denominator of 9. That second fraction already has it. Here I have to multiply top and bottom by 3, so I get 12 ninths. 12 plus 4, 16 ninths. And then square root, x minus 2/3 equals plus or minus, square root of 16 is 4, square root of 9 is 3. I then add a 2/3, x equals 2/3 plus or minus 4/3. Now, I normally stop right here. I do that when there's a radical in here because there's not much more I can do with it. But if there's no radical, do not stop there. Carry out that plus and that minus. So there are two answers that are hiding there. 2/3 plus 4/3 and 2/3 minus 4/3. When I do that, 2/3 plus 4/3 is 6/3 or 2. This is negative 2/3, and we got that. Okay? Now, another thing that I want you to realize, when you do completing the square, and there's no radical left here, that means this was factorable to begin with. If you brought that negative 4 over and you got a 0 on one side, you were able to use guess and check to factor that. Please don't think, well, why did I do it? You still solved it. Okay, and again, the point right now is so you can get this process down. But when you do get the answers that come out nicely like this, it was factorable at the beginning. Okay, just be aware of that. So again, completing the square is not a standalone thing. Square root method, square root property, that's a great way of solving certain types of quadratics. But not very many fall into that category where we have a squared part that we can isolate. Okay, completing the square creates a situation where we can use the square root property. That can be done to any quadratic that I would hand you. Okay, you may not have to. You may look at it and say, oh, it's factorable. Oh, I can use the square root property already. But if neither of those are happening, the completing the square will help you set up a situation where you can use the square root property. Okay, so get that process down. Just keep practicing so it's a routine. We want this to be a routine. This is just a tool that we want to use to solve certain problems. Okay, so when we set up a certain situation given a word problem, we can then fall back on this method to get the job done. Okay, so as always, work hard. Let me know if you have any questions, and I'll see you next time.